This video is in conjunction with homework 8-1. It's going to introduce recursive formulas for recursive sequences. So today we started talking about sequences. We talked about how it's a string of terms or a pattern of terms that they display some kind of pattern. And we use the formulas that are located on the reference table for the explicit formula. Today we're going to talk about how to define a sequence in a different way. And that way is using the previous term to dictate the formula. So as you can see here, it says the word recursive. It says a recursive formula generates a sequence by using the previous term. There are critical aspects when writing a recursive formula, and they are listed here. There are two parts of it. So the first thing you need to know is recursive has the prefix re, and re means go back. So record, rewind, repeat means go back, go back, go back, go back. So when you think of recursive, I want you to think about go back to the previous term and use that previous term to get to the next term. So there are two parts of the recursive formula. You need, first of all, the initial term, which is your starting term. That's called a sub 1. And then you also need part 2, a formula using some kind of expression that involves the previous term. You're going to see it right now. So this says fill in the chart below using the missing terms. Pretend like you're on a ladder and you're going up the ladder rungs. To get to the next rung, you need the previous rung to get there. So you need to climb up, climb up, climb up using the previous term. In this case, if you are starting at a sub 1, the term after it is called a sub 2. Well, what's the term before it called? The previous term would be 1 less than a1. So that is called a sub 0. It's 1 less n. So if I'm at A4, the one after A4 is called A5, and the one before it would be A4 minus 1, which is A3. So if I'm at A sub n plus 1, the one after it would be A n plus 2, because it's 1 more than n plus 1. The one before it would be A n plus 1 minus 1, which is really A n. It's 1 less. If I'm at A n, the one after it would be a n plus 1, because you have to add 1 to get to the next term, like 1 to 2, etc., 4 to 5, n to n plus 1. So the one before it would be 1, subtract 1 from n. So it would be a and n minus 1, because 1 to 0, 4 to 3, n to n minus 1. One more, a n plus 6, the next one after it would be n plus 7. So the one before it would be n plus 5. All right, so keep that in mind with the subscripts. We would just be either adding 1 or subtracting 1. And if we're using the previous term, which we are in these formulas, we're going to be looking at this kind of notation here. We're going to go backwards 1 term to define our formula. So now it says the terms of a sequence are listed by subscripts A1, A2, A3, A4, etc. Example 1, here they are. Let's first state A1. A1 is 4. A2 is 7. A3 is 10. And A4 is 13. So how do we get from one term to the next? Ask yourself, what is the pattern you see to get from 4 to 7 to 10 to 13? I'm hoping you're saying add 3 to the previous term. And because we're adding, that means that this is an arithmetic sequence, because remember, arithmetic uses addition and subtraction. Arithmetic add. So if I want to make a recursive formula with this, I need my 2 pieces. My 2 pieces are my starting term, which is A1, which is 4. So this is saying start at 4, and then a formula that involves using the previous term. So if I'm at AN, the term before it, the previous term, what I want to do with it is, according to this, I want to add 3 to the previous term. Add 3 to the previous term. Add 3 to the previous term. So if the previous term of AN is A, if you look back up to here, The previous term of an is an minus 1. I'm going to do an minus 1 and then plus 3. So this is the formula that defines the recursive sequence. It has the two pieces, 1, 2. So now we're done. We're done with this question. Now let's look at number 2. What is the pattern from here to here? I'm hoping you're saying times 2, times 2, times 2. And remember, if you are multiplying the previous term by 2, then that is called geometric. Okay? That 2 is called the common ratio, R. So to get my two pieces, 1, 2, my first piece is I state the first term. And then I'm going to state something involving the previous term. Okay? So the first term is a1 equals 2. That's my first term, my initial term. And then I'm going to take the previous term times 2. Previous term times 2. Previous term times 2. Previous term, write it down in words, it helps, times 2. Okay? So an, the previous term would be an minus 1 times 2. Now, yours could be done technically like this, but if you like, you could rewrite this piece because it looks a little ugly as an equals 2 an minus 1. So I'm going to rewrite it as a1 equals 2 and an equals 2 times an minus 1. So if you like, you could put it in parentheses. You don't have to because technically it's connected by addition. And we are done. Part 1, part 2. Two pieces of the recursive sequence. All right, let's do one more. What is the pattern that you see here? I'm hoping you're saying add 5 to the previous term, add 5 to the previous term, add 5 to the previous term. Because I'm adding 5, that is called arithmetic, and that 5 is called the common difference. So we're going to do our two pieces, piece 1 and piece 2. Piece 1 is a1, and then piece 2 is the an part. So the first term was a1 equals negative 11. So this is saying start at negative 11. And then we're going to do what? We're going to do previous term plus 5. Previous term plus 5. Now we're done.